So today, we're going to talk about JupyterLab, which is the evolution of the Jupyter Notebook. But there's a lot of names on this slide. I just want to point out, so my name is Jason Grout. I work for Bloomberg in New York. Three of the main key players in JupyterLab are Chris Colbert, who has worked for several years now developing the foundation of JupyterLab, which we'll see a little bit later, as well as sort of envisioning what the final product might look like and helping guide the architecture discussion. So a big shout out to Chris, as well as Steve and Darian, who have been doing a huge amount of work in actually developing the code. Brian Granger, Sylvan Corley, Cameron Olson, Fernando Perez, David Wilmer, who also worked on JupyterLab for a while, Cal Poly students and the larger Jupyter team. This is a huge effort, and it's an effort to evolve the Jupyter Notebook into something that's even better than what we have today. So, by a quick show of hands, how many people know what the Jupyter Notebook is? How many people have used the Jupyter Notebook? Okay, so I won't preach to the choir too much. This is Jupyter Notebook has taken the world by storm in some sense. It's an interactive environment that lets you do exploratory data analysis, and one of the key things it brings to the picture is a reproducible document format that combines code and narrative text, equations, etc. It's built on top of the Jupyter platform, which is a platform that specifies protocols and messages and reference implementations of tools that allow us to connect to many different programming languages in many different environments. And everything's open source, BSD licensed. For the benefit of the video, here's a short screen capture of what the Jupyter Notebook looks like today. So where are we today in Project Jupyter? We had a survey a couple of years ago. We estimate we have about 3 million users. You'll see the breakdown of the users that we estimate, and you see that science and data science and education are well represented up at the top, and as well as developers. We have quite a number of notebooks that are pervading the world. Here's a huge amount of notebooks that are on GitHub. In fact, GitHub now has rendering of Jupyter notebooks, so it's easy to view them. Over 500,000 notebooks, as well as a trending page on GitHub that you can go to see popular notebooks. The Jupyter Notebook is enabling reproducible science. So here's one of the momentous discoveries from the last little while recently. The LIGO experiment has produced some measurements of gravity waves, and what was great is that they published and all their data in form of Jupyter notebooks. Anybody in the world could download their data, play with the data, reproduce their analysis. Amazing steps in enabling reproducible science and giving it to the masses. Of course, it was a quite sophisticated analysis, so we have other people in more popular culture using Jupyter notebooks to share their data and analysis. So BuzzFeed in particular has been publishing notebooks for their articles. Here's an article on the tennis racket, and the notebooks are all available on GitHub. So we see the notebook enabling people sharing their data analysis, not only in hardcore science, but also in popular articles. The Jupyter Notebook, of course, is more than just a notebook. It's evolved into some other building blocks that are needed in data science. We have a file browser in the upper right, a code editor in the upper left, a terminal, and of course, the actual notebook. And we have a few more notebooks, or a few more building blocks in this platform of tools that you can use for scientific computation. So a file browser, of course, the other things that you've seen, kernels that allow us to talk to many different languages, Julia, R, Python, many other languages, as well as a flexible output format and a way of presenting output in a way that's engaging and interactive. But these building blocks are all comprising what we now call the Jupyter Notebook. So what are we hearing from users? In this survey that we mentioned before, we asked for feedback, and we found that most people use it daily or weekly, so quite often. People love the notebook workflow and the idea of a notebook environment and the user experience of the notebook, but they pointed out a lot of needs. And we see these needs particularly when people start to transition from a notebook type environment to more hard coding environments, or taking their data analysis from an exploratory data analysis to building libraries built on this. And so things like integration with version control systems, improved code and text editing instead of just notebooks, layouts, being able to put your code editor next to your notebook, or your terminal next to your code editor next to your notebook. In the current notebook, they can only be on a single page. Each thing is on a single page. Can we have better integration between these tools? And also tools that are more aligned with software development, debuggers, profilers, variable inspectors, etc. So this brings us to JupyterLab. And I want to emphasize that we're at the alpha stage for JupyterLab. Everything that you'll see today is alpha preview level. Hopefully we won't demonstrate that. Hopefully you'll just believe me in saying that. JupyterLab is a natural evolution of the notebook. You might say it's an interactive development environment where we have interactive data analysis. We have a flexible UI that lets us assemble these building blocks, put them side by side with each other, work between them, in order to up the power of the environment. It's built on a modern JavaScript architecture. We use NPM, Webpack, a plugin system that was designed from scratch. We have model view separation. We're using TypeScript. There's a bunch of buzzwords for you. But the point is that we're trying to take advantage of the current state-of-the-art in online architecture and development. It's built on Phosphor.js, which is a library built by Chris Colbert over the last few years, which enables the plugin architecture and some of the things that we'll see later. You can think of Phosphor.js as a collection of components for a web application, an extensible performant web application. We paid a lot of attention to design. We have a few designers working with us. We've done user testing. We're trying to be really careful about the user experience in this environment. And everything, of course, is open source BSD licensed. All right, let's see some demos. How many people were at SciPy when we gave a previous version of this talk? How many people listened to the talk online? It was published online. Okay, great. Those of you that were at SciPy a few months ago where we announced this originally, you'll see some new stuff. Everyone else, you'll see a lot of cool stuff here. So when you launch JupyterLab, you end up with an environment like this. And it has a number of the building blocks that we mentioned before, but in more refined and powerful form. So over on the left-hand side, we have a file browser. And the file browser lets us do common operations like renaming, deleting, cutting, copying and pasting files, downloading files, etc. In fact, in order to move a file or rename a file, you can click on the file to rename it. You can move it by dragging and dropping it. You can drag and drop it into one of these folders, and you'll see there we are. And in fact, you can even drag and drop it up into the little directory structure up there. I'm sorry? These are files, just like the Jupyter Notebook, these are files served up by the Jupyter server, so wherever your Jupyter server is running. Actually, it's whatever your contents manager, which is a pluggable part of the Jupyter server, whatever your contents manager is exposing to the UI. I'm going to open up a few files. So we have a code editor. So here's a short run through of what we'll be talking about today. This is editing a markdown file. We also have a notebook. So for example, here's a standard notebook. This is a slight modification of the widgets examples. And what do we need more of on the internet but pictures of cute cats? And of course, even better than pictures of cute cats is pictures of fuzzy green cute cats. And this is a standard notebook, and just like the normal notebooks, we have interactive controls. So we can make the cat as cute and fuzzy and green as we want. Yes. Sorry, font is a little bit bigger. Is that better? Okay. So we have standard notebooks that we see. Notebooks are approaching feature parity with the current notebook. There still are niggling either bugs or minor user experience issues. But it's probably good enough that a sophisticated user that wanted to file bug reports could start using it. We also have a text editor. So here's a Markdown file, and here's a Python file, for example. I'm going to make it just a little bit smaller because to fit more on the page here. We also have a terminal. So this is a full terminal. And we have a Python console, actually a console for any of the kernels in the environment. 1 + 3 is 4. And this is similar to the Qt console, but in a web format. And with all of these tools, this is somewhat like the state-of-the-art with the current notebook, where you can have the tools one at a time, but we wanted to enable something more powerful than that, so we allow you to drag and drop these tools to whatever arrangement you would like here. So often you'll have a Python file, a terminal, and a console side by side. And of course, these are splitters, so you can change your environment however you need. We can also, this drag and drop experience works with the file browser as well. So here's a PNG file. We can drag it in, put it wherever we want. And more than just arranging the tools together, the next step is to actually make the tools work with each other. So as an example, let me open up this Markdown file. And this Markdown file has a bunch of text and code. And what I want to do is actually run the code. And instead of actually copying and pasting it, we can make this work a little bit better if we start up a new console. In order to start up the new console, I'm going to introduce one more tool, and that is the command palette. So as is popular in many IDEs these days, we have a command palette that lists the commands and keyboard shortcuts in the environment, has fuzzy searching. So let's see. Let's create a console for this text editor, Python 3 console. And so this console is hooked up to this text editor so that I can just take this code, and I'm going to press Shift-Enter, and you'll see it copies it over into the console. So what we have here is an environment that many people are used to in other tools where you can work with a text file. It doesn't have to just be a code file, though. It could be any text file. And code is automatically put into the console. It's a little hard to see because it's cut off at the bottom, but there's an input right over here. And you can type in whatever else you want. You can interact with this console, and you have your interactive session over in the corner. Of course, one line at a time is a little limiting, but you can also do entire blocks of code. So here's an import, and say we're working through this data. So we have a data frame right here, and suppose we wanted to make a scatter plot. Here's a scatter plot, all in line in the console. So quite handy, quite nice to work with tools and work between tools. Sometimes, though, you want to do more than just see things over here in the corner. So what we've done is, as well as putting tools together and letting you use the tools together, we also let you take the tools apart. So I want to just maybe put this image up here so I can see the image. And I can drag any output anywhere I want, have a copy of that output, and now I can keep working in this terminal here. So here's my data file, my data, and the image, the copy of that output stays where I want it. And of course, this works as well with the notebook. If we go back to our previous notebook example, this notebook example had an interactive control here. And often when I'm dealing with a notebook, I would like to just have sort of a dashboard type environment. And so, of course, I can drag this output over here. And now I have a dashboard-like environment over here. I don't have the notebook, I just have a copy of that single output as its own entity. And you see it's really a copy of that output. As I move the sliders, you see the sliders in the original thing, in the original notebook working as well. Of course, this leads to the following workflow where I take this output, instead of dragging it over here, I just drag this output right on top of the notebook, and now I have my dashboard-like environment from my notebook. Take any output you want, drag it on top of that notebook, and now you have an environment that you can arrange however you want, use interactive controls, and interact with here. And of course, it wouldn't be complete without saying, if I really want to interact with this environment with 4 different variables, I'd get out the fun things and use my game controller in order to modify these sliders in real time here. So now we have simple dashboarding in the notebook, simple dashboarding capabilities. Question? Yeah, so what you'll see here is we used, a question was if we have a number of widgets, can we arrange them all into a single dashboard? What we did here was we used the interactive command in IPython, which automatically lays out several sliders and the output of a function. You have a lot more advanced capabilities for laying out widgets as well. If you can construct it into a single output, then you can drag that single output wherever you want. So you would use the functionality from the widgets to lay out things however you want and then drag it off to the side. It's literally just another view of that exact same output. It's just a copy of that output, but set apart from the notebook. Other questions? This is one of the exciting new things. And what's really exciting about this is this was implemented at SciPy during the sprints. The bulk of it was implemented in just a few hours by a person that had no JupyterLab experience, sitting down with somebody that had experience, but he did the bulk of the code in just a few hours, and that shows some of the power and the extensibility and flexibility of this platform. So the sky's the limit here. Let's go back to our talk. One of the things that we see from that example is that even people with little or no experience with JupyterLab or JavaScript development can start to customize the environment for their needs. And so one of the things that we've tried to build is here is an extensible platform with respect to file types. So you already saw that I could drag a PNG file over and have a PNG rendered. This is provided by a plugin that's a self-contained plugin. But we have more sorts of things than that. Close down a few things here. For example, here's that markdown file that we just had, and we can at the same time view it in a different way as a rendered markdown file. And so these are connected to the same live model, and you can see that by you can see that it's a live model. The markdown files, the different views of the same markdown file are linked together here. So we have live code editing with the different views of the same file.
Can you change the CSS file for that markdown?
Mm-hmm. Yeah. So, question about customizability. Can you change the CSS? Actually, we've one of the other new things since SciPy is that we've introduced a complete theming for the environment that's based on CSS variables, and there's many things here that you can customize pretty easily. We don't have a built-in theme editor yet, but that's on the roadmap plans. But certainly you can change the CSS, and particularly you can change variables that are used all throughout the platform to change various looks of various elements. But of course, it's open source, so you can change everything, anything that you want. So one of the things that we do a lot with as data scientists is we work with data. And oftentimes we have things like a CSV file or some data file, and if we want to see this file nicely, then we pull open the notebook and we run a command like read CSV. Here's the standard iris data set, and we get a nice display for this thing. But if we just want to look at the file, opening a notebook is pretty heavyweight. So the other option that we have is we could open the file and just parse it by hand here. That's no fun. You could open it in Excel, but then you have to go to another tool. wouldn't it be nice if you could just double-click on the file and have a table show up? So this is a renderer that renders CSV files in a way that looks pretty nice for looking at it. And similarly, what if you have, the weekend here? It's Washington, D.C. There's tons of museums around here. So, of course, as data geeks, what we do is we download the museums in D.C. GeoJSON file and try to plot out our route. And you see here we have various museums in latitude and longitude, but it's very hard to see where the museums actually are, get a sense for this data file. So wouldn't it be nice if you could just like double-click on the GeoJSON file and have it rendered on a map? This is the sort of power that we're enabling here. This plugin was largely written in about an hour in a sleep-deprived state a few months ago, and it lets us easily take advantage of the leaflet library to view a GeoJSON file. And again, it's live. If I actually open the GeoJSON file, I've always wanted, when I learned about the Poetry Museum, the Poetry Museum is amazing. Wouldn't it be nice if the Poetry Museum was in, say, New York? We could just change this, and you can see that okay, we could put the Poetry Museum in Pennsylvania, I guess. But the point is that there's a live connection between these different views of the file here. So you have data files, you have rendered views of data files, and they all work together. Are the rendered views what? Yes, the rendered views can be anything that you want. We have 2 rendered views here. You could easily make that map so you can drag things around and it will update the GeoJSON file, for example.
Do you have an option to specify the delimiter of CSV format?
Like this one? Yeah, so this is actually an option that someone came to us and said, I'd like to do tab-separated files. And then somebody else came along and implemented a delimiter. And the code for this is actually not that hard, not that complicated, and it'd be easy to make a little input docs that would let you put your own delimiter in. Yeah, so the sky is the limit. And this is the genius of open source, right? That you can shape the tools for whatever workflow that you have. The front end is entirely written in TypeScript, which is a typed version of JavaScript. Yeah, good question. The delimiter changing here, what we're using is we're using the D3 library for parsing CSV files, and the delimiter is an option to D3 in order to, and so what this is doing is it's triggering a change in a function call in JavaScript that's calling D3 again to parse the CSV file again and then render the CSV file again. Good question. The question is, can you call Python on the server and actually do some back and forth computation? In order to do that, you'd need to hook up to a kernel, which is a little bit more complicated. We have ability to hook kernels to text files. We have the ability to hook kernels to really any viewer. And so you would need to start up a kernel, and then you could interact with a Python session in order to work with a view of a file. Yeah, so definitely possible, and that's what we're doing in the notebook, essentially. Even things like, here's a JSON file that is a declarative description of a chart in the Vega format. We've been experimenting, Brian Granger and Jake Vanderplas especially have been experimenting a lot with this recently, but again, we can just call the Vega renderer and see that same JSON file actually rendered using the JavaScript plotting library. So flexible, pluggable renderers, flexible, pluggable views on any file that you want. And the sky's the limit here for what kind of views and what kind of tools you want to edit your files. So I've mentioned this several times, but the exciting thing about JupyterLab is not so much the tools that we're giving you. It's that we're giving you the platform to build your own tools as well. And this is really the genius of open source, that you're welcome to dive as deep as you want, shape the tools to your heart's content. And just like Jupyter, the Jupyter Notebook or even JupyterLab, the exciting thing about the Jupyter project is not so much the reference implementations that we're handing you, though those are awesome. It's the underlying protocol and messaging spec that allows any number of tools, Interact.io and Beaker and other platforms, to all engage in the same ecosystem and work together, use the same kernels, etc., and build in the same platform. So everything is a plugin. You can see this by looking at the actual code of JupyterLab. Here's the heart of JupyterLab. And you can see here what we're doing essentially is loading every component that you see in the UI here as a separate plugin. So for example, here's the notebook plugin. Here's the main menu plugin. Everything here is a plugin. And every plugin that you write in the system is an equal first-class citizen with every one of these plugins. And so, for example, the GeoJSON editor is a third-party plugin. It's not one of the things listed here. We've developed it outside of JupyterLab. We've installed it as a JupyterLab extension, and it participates with the system on equal footing with every other plugin in the system. And plugins in JupyterLab, they can, for example, add things to the command palette, add things to the menu, add viewers for documents, like we've seen here, for example, with the map. They can expose other controls. So, for example, there's an experiment writing a complete separate tab panel that'll control or give insight into a DAS calculation. Perhaps there could be another panel that controls a Spark cluster. The sky's the limit of what kinds of controls that you want to enable here, and you can participate in the ecosystem in the JupyterLab environment on equal footing with everything else. You can also expose capabilities to other plugins. So, for example, the widgets that you saw with the cat example, that's a plugin that's installed into the system just like any other plugin that you would write and publish onto PyPI. And it exposes capabilities for other people to write widgets and build on top of the plugin that you've installed. So we have a flexible system of plugins. Every plugin is exactly on equal footing with every other plugin. You can mix and match. You can even delete plugins if you'd like to make your own customized environment. That's really the power of JupyterLab here. So the power of JupyterLab is the community, you guys. I'm excited to see what kind of plugins that you guys build. Some examples, of course, of the GeoJSON file handler. We even have a cookie cutter recipe for designing and implementing, starting out with a simple plugin, and then you can take it to your heart's content. And really, the big question is, what will you build with the JupyterLab ecosystem? So, quick wrap up. Today, JupyterLab is early alpha preview only. I've taken to carrying Band-Aids in my backpack. Sometimes you get cut on the bleeding edge. It's probably okay for a really sophisticated user to start using it and giving us feedback. Some of us have started using it as our notebook replacement, as our computing environment. But keep in mind, it's still alpha, which means that things are changing rapidly, designs changing rapidly, codes changing rapidly. There's dozens of pull requests emerged each week. So we're not suggesting it for general usage yet. The roadmap for the future is we're going to have a series of alpha and beta releases where this is sitting alongside the current notebook. Right now we release it as a server extension, so you install it into the current notebook server, and then you have a new command, Jupyter Space Lab, to launch it, but it doesn't touch your current notebook. When we get to the point where we think it's feature parity and ready for general usage, then we'll release JupyterLab 1.0, maybe in the first half of next year-ish, if everything goes well. Then we'll have both the feature parity JupyterLab and the Jupyter Notebook side by side, and then it'll be ready for general usage. And then eventually the JupyterLab will be the default UI, and the classic notebook will still be available, or possibly after a while available as a separate download, and it'll be completely replaced with the JupyterLab UI. In order to install the alpha level preview, remember, you can either use pip or Conda, the Conda Forge channel. Pip install JupyterLab. You have to enable the Jupyter server extension if you're installing from pip, and then you can do Jupyter Space Lab instead of Jupyter Space Notebook to launch the lab. Or you can install it using Conda, which does the server extension enabling step by itself. I'd like to give special thanks to the Project Jupyter community, which includes not just the developers, but all of you. And particular thanks to the partnership. This is all made possible by a partnership between Bloomberg, my employer, and Continuum Analytics, where Chris Colbert, Steve Sylvester, and Darian work, among others, and the Jupyter community and Jupyter developers at large. Jupyter, of course, is supported a lot by the Moore, Sloan, and Helmsley foundations. Particularly, Brian Granger's been working a lot on this project, as well as the Cal Poly students that he's hired have been doing a lot of design work and code work. Of course, Jupyter, we'd like to give a special thanks to NumFocus for their support for the Jupyter project. If you want to contact us, we're pretty active on the Gitter channel. There's also the Jupyter Google group, or of course, you can go look at the code. Thank you very much. I think we have time for some questions. Yeah.
Anybody currently working on the object inspector?
Not that I know of, but we are really hoping that somebody takes this up. Are you, any volunteers are welcome to join us and to work on some of these tools. Like we said, right now we've concentrated a lot on building a feature parity platform for and a platform that enables people to work on individual components that are useful. So an object inspector, a debugger. I'd love to see a debugger. I'd love to see a data browser of some kind. There's lots of tools that we would love to see, but I don't know of anybody that's working on an object inspector right now.
Looking at the roadmap, it seems like a slow departure from the computational narrative philosophy that kind of like drove the notebook like interface. And I was wondering what drove the decision to make it more IDE like.
So the question is, the roadmap seems like it's moving more towards IDE than just the classic notebook where we had just a single document on a page. Is that a fair statement?
It's like, intentional departure from like, tell story output, and more into like now RStudio.
So the question is, before we had story-oriented documents, and now we have an IDE-like environment. And one thing I'd like to emphasize is we're not losing anything. We still have the entire notebook in the way it was. We're trying to get a feature parity notebook that's still a story-oriented document format. And you could just live just with the documents if you wanted to. But what we saw was that people were facing a lot of friction when trying to move between a software development stance where you're developing libraries, where you need a text editor, where you need a terminal, et cetera. And people were having to sort of pull these things in from other places or try to get them as separate applications to work with the kernel and the server, et cetera, and bringing them all into a single environment where you can interact. Now all of a sudden you can not just do story-oriented documents, but you can interact between documents and a text file and a library file and documents and a console. And so it's not so much a departure from the notebook. We have and we really value that experience. It's adding these other tools and making everything work together in an integrated way that we're trying to do.
So I walked in late, so you might have covered this at the beginning, but how does the format and hosting and like the files that come out of this, is it the same sort of JSON type document that I can just host anywhere, or is there like, how do I like bring this into my team's architecture?
So the question is, what are the differences on the server side, bringing things into the architecture? So the thing about JupyterLab is it's completely on the client side, completely on the web side, on the browser side. The Jupyter server is exactly the same. I'm running right now on Jupyter Notebook Server 4.2.3. And so there's no change on the server side. We might introduce some changes as we see some limitations with the Jupyter server with the expanded capabilities we have on the web, on the browser side. But JupyterLab itself is entirely a JavaScript application. It's just about interacting with the server and the files that are already existing on the server side. No change to the server side. Does that answer your question?
Yeah, but it sounds like it's just a different extension that when it opens, it pulls in a different JavaScript library.
It's a different web application than the current notebook, but the server stays the same. Yep.
There are a couple of legacy plugins that I've looked at some current notebooks, like the 90% presentation mode and the dashboard kind of layout. How would this ever relate to those kind of plugins?
Yeah, that's a really good question. One thing that I didn't put on this roadmap is working with third-party extension authors like NB Present. The question was, what about the extensions that we know and love from the current notebook, like NB Present and other extensions that people have written? One of the things we're really concerned about and serious about giving a lot of help for is in this switch to JupyterLab, bringing along the extensions, either providing an API that we can write to that will enable both platforms, or maybe more likely helping authors migrate extensions to the JupyterLab platform. I think what we'll find is that the JupyterLab platform enables much cleaner extensions and much more powerful extensions than the old Jupyter Notebook. And so we definitely want to bring along the extensions that we know and love from the Jupyter Notebook. One more question.
Is there any path towards multi-monitor support for panels?
Good question. Multi-monitor support. So one of the things that's in the roadmap for Phosphor. So Phosphor is the underlying application shell and widgets and other libraries for designing the application. One of the things that we want to do in the underlying Phosphor library is make it so that any one of these tab panels can be popped out to a child window, and then you could move it to a separate monitor, and it would still be part of the same application browser instance, but living in a separate window on your windowing system and move to a separate monitor.
Can you talk a little bit about the security, change the security model you can find? If there is, what capabilities we have along with that?
Question is about the security model between the client and the server. So right now we're trying to preserve feature parity with the notebook, so we have the concept of trusted notebooks. We have not done very much on the client side, on the browser side, to enhance security, for example, running things in iframes and stuff like that. We've been trying to emphasize the feature parity part first, but there's discussions on the table about how do we run JavaScript code in a sandbox context? Is it feasible to do so? We'd love to continue discussions if you'd like to join us talking about security. Question is about authenticating. Okay, so right, so encrypting traffic, for example, between the server, authenticating to the server, these are really the purview of Jupyter Hub. JupyterLab, just like Jupyter Notebook, has no concept of users. It's just an application that's interacting with a server. Jupyter Hub is the one that handles authentication, for example, routing requests to various servers depending on who's authenticated and what privileges people have. And we're working closely with the Jupyter Hub community to be able to integrate JupyterLab into that environment. So we're doing the sort of Jupyter Notebook part and integrating with the other pieces of the Jupyter system for doing authentication. And of course, you can run this on SSL to encrypt traffic, et cetera.
Yeah, so you mentioned some other languages that you were using to develop this. Are there opportunities to contribute in Python in particular?
Yeah, right now the front end. So the question is, are there opportunities to contribute to JupyterLab in Python? Right now, most of the work has been done on the browser side here, this TypeScript application. There are some changes that we would love to do to the server to enable some more powerful ways of interacting with things. Those are places where we can jump in with Python. There's been small changes to the Python server that we've needed to make as we went along. And there's more major changes to the Python server that we would like to make, but but we're trying to get feature parity first and then take a step back and look at, okay, what server changes do we need? So definitely places that we can work on the Python side. Come talk to me. We've got some good ideas. Any other questions? All right, thank you very much. And again, as users, the cool thing about open source is that you're not just users, you're developers too. So thank you in advance for all the wonderful plugins and all the wonderful things that you're going to create for the notebook the lab environment that I'll be using. So thank you.